Welcome to the introduction to number bases and measurement units for ICT beginners. In this lesson, you'll learn the basics of number bases and measurement units that are commonly used in computing. Understanding these concepts is essential for anyone interested in pursuing a career in information and communication technology. Let's get started. Number bases and their applications. Number bases are the foundation of computing. They are used to represent numbers in a way that computers can understand. In this section, you will learn about the most used number bases in computing, including binary, octal, and hexadecimal. You'll also learn how to convert between number bases and how to use them in practical applications. Understanding measurement units. Measurement units are used to quantify data in computing. In this section, you'll learn about the different measurement units used in computing, including bits, bytes, and megabytes. You'll also learn how to convert between them and how to use them in practical applications. Conversions between number bases and measurement units. In this section, you'll learn how to convert between number bases and measurement units. You'll be provided with a step-by-step process for converting between them, and practical examples will be given to help you understand how to use them in real-world scenarios. Calculating with error in mind. In computing, errors can occur during calculations. In this section, you'll learn about the concept of error in computing and ways to minimize and deal with errors in calculations. This will help you to ensure that your calculations are accurate and reliable. Number bases and their applications. Number bases are a way of representing numbers. In computing, we use different number bases to represent data. The most common number bases used in computing are binary, octal, and hexadecimal. Binary number base. Binary is the number base that uses only two digits, 0 and 1. It is used in computing because it is easy to represent data using electrical signals that can either be on or off. Octal number base. Octal is the number base that uses 8 digits, 0 to 7. It is used in computing because it is easy to convert between binary and octal. Hexadecimal number base. Hexadecimal is the number base that uses 16 digits, 0 to 9 and A to F. It is used in computing because it is easy to convert between binary and hexadecimal. Converting between number bases. Converting between number bases is an important skill in computing. It is often necessary to convert data from one number base to another. Measurement units. Measurement units are used to measure physical quantities such as length, weight, and time. In computing, we use measurement units to measure data storage and data transfer. Understanding measurement units. The fundamental unit of information in computing is the bit. A bit can only have two possible values, 0 or 1. A byte is a group of 8 bits. A kilobyte is 1024 bytes. A megabyte is 1024 kilobytes. Conversions between number bases and measurement units. Conversions between number bases. Number bases are different ways of representing numbers. The most common number bases are decimal, base 10, binary, base 2, and hexadecimal, base 16. Converting between number bases is a process of changing the representation of a number from one base to another. Here's a step-by-step process for converting between number bases. The process for converting a number base from one to another is as follows. Write the number in the original base. Divide the number by the base you want to convert to. Write down the remainder. Divide the quotient from the previous step by the new base. Write down the remainder. Repeat step 4 and 5 until the quotient is 0. Write the remainders in reverse order. Example of converting binary to decimal. To convert the binary number 1011 to decimal, we use the following steps. Step 1. Write the number in binary 1011. Step 2. Starting with the rightmost digit, multiply each digit by 2 raised to the power of its position. The rightmost digit is in position 0. So, 1 times 2 raised by 0 is 1. 1 times 2 raised to the power of 1 equals 2. 0 times 2 raised to the power of 2 equals 0. And 1 times 2 raised to the power of 3 equals 8. Add up the results from step 2. 1 plus 2 plus 0 plus 8 equals 11. The decimal equivalent of the binary number 1011 is 11. Conversions between measurement units. Measurement units are used to quantify physical quantities like length, time, temperature, and weight. The most common measurement units are the International System of Units. Converting between measurement units is a process of changing the representation of a quantity from one unit to another. Here's a step-by-step process for converting between measurement units. The process for converting a quantity from one unit to another is as follows. Write down the starting quantity with its unit. Identify the conversion factor between the starting unit and the target unit. Multiply the starting quantity by the conversion factor. Write down the result with the target unit. Example of converting Celsius to Fahrenheit. To convert 25 degrees Celsius to Fahrenheit, we use the following steps. Write down the starting quantity with its unit, 25 degrees Celsius. Identify the conversion factor between Celsius and Fahrenheit. Fahrenheit equals Celsius times 1.8 plus 32. Substitute the starting quantity into conversion factor. Fahrenheit equals 25 times 1.8 plus 32 equals 77. Write down the result with the target unit, 77 degrees Fahrenheit. Calculating with error in mind. When working with numbers in computing, it's important to keep in mind that errors can occur. What is an error in computing? Error in computing is the difference between the expected result of a calculation and the actual result. What causes error in computing? Error in computing can be caused by a variety of factors including human error, hardware failure, software bugs, data entry mistakes. Types of error in computing. There are two main types of error in computing: systematic and random. What is systematic error? Systematic error is an error that constantly occurs in the same direction. What is random error? Random error is an error that cannot be predicted and occurs randomly. To minimize error in computing, it's important to double-check your work. How to minimize error in computing? Verify your inputs. Use built-in functions when possible. Check your work twice. Use appropriate measurement units. This brings us to the end of our lesson. Thank you for joining.